All right, so now that we've gone over the beta function, the gamma function, the connection between the two, we're going to work out a problem using the beta function. Now, that's a big hint because the problem in of itself doesn't have the beta function in it. Sorry, not 0. We're going to start at n equals 1. We're going to go to infinity. And then the summand is just going to be gamma squared of n over gamma of 2n. And if you watched my last video, this looks really familiar, because this is actually what happens if you plug in n and n for the arguments of the beta function. Now, if you don't understand what I'm talking about, we found this relation 2 videos ago in this series talking about the gamma function. So gamma of x times gamma of y over gamma of x plus y, this is just a beta function with arguments x and y. Okay, so notice that if you go ahead and plug in n and n for both of these, you get that the left-hand side just becomes this summand. The right-hand side is just beta of n comma n. So we can continue this problem by rewriting this, sorry, not 0, 1, using the beta function, because this right here is just beta of n comma n. But how does this help us at all? Well, it's because we know how to write the beta function in terms of an integral, and we know how to solve integrals. So the beta function, if you guys don't remember, I'm going to just write this notational shorthand, okay? N is greater than or equal to 1. It's still going to be over the natural numbers. Beta function is defined as the integral from 0 to 1. We have t to the first argument, minus 1. So that's going to be n minus 1. And then we have 1 minus t to the second argument, minus 1. So that's going to be also going to be n minus 1. And then close it with the dt. Okay, now the integrand right here is simplifiable really nicely because they both have the same power. That means you can multiply the bases together. So we're on the inside here, we're going to have t times 1 minus t all to the power of n minus 1. Okay, so that's our integrand. Now we're going to go ahead and interchange the order of integration and summation by dominated convergence. So yeah, okay, let's go ahead and do that. Integral is going to go on the outside now. Now, why do we want the sum on the inside? Well, it's because here, this right here kind of looks like the geometric series, okay? Let's just write this down really quickly. If you guys remember, if you have k being greater or equal to 0, and you have the function x to the k, well, as long as k is in between 0 and 1, which here obviously it is because t is in between 0 and 1, 1 minus t is also between 0 and 1. Okay, you'll figure that out in a second by just plugging in the extreme bounds for this second factor there. Okay, this is just equal to 1 over 1 minus x. And that is so much easier to work with. So let's go ahead and do that. We're going to have the integral from 0 to 1. That comes from here. And then this sum of this integrand. Now, notice that here, if we start at n equals 1, this power is going to start at 0. And then as we go through the powers, this is going to go up 1 by 1 by 1. And that is exactly equal to what's going on here. So we can go ahead and straight up just rewrite this integrand as that. And you can get the index to be the same. Just doing some slight reindexing, you can actually... the reindexing is going to look like this. You're going to start at n equals 0, and then the power is going to become just n by itself. So you see that this obviously matches. So therefore, let's go ahead and write that in. 1 over 1 minus x, except x is that. So t times 1 minus t. All right, and then we're going to have the dt. Now, I'm going to get rid of this. We can straight up just integrate this now, because it's just a very simple, 1 over quadratic situation. Integral from 0 to 1, I'm going to have the dt on top. This 1 is going to stay. And then after we expand it out, we're going to have this negative t times 1, which is just a negative t. And then we're going to have this negative t times this negative t, which is going to be a plus t squared. Now, we're going to be completing the square to solve this and using the arctangent antiderivative formula. So, to complete the square for this, we take the coefficient of the middle term, square it, and then divide by 4. And that's the number that we want to add and subtract on the side. So to complete the square, we take -1, okay, we square it and then divide it by 4. At the end of the day, this is going to work out to 1 over 4. So what are we going to be doing? We're going to be integrating from 0 to 1. That 1 is going to stay for now. We're going to want to add a 1 over 4 to complete the square. Okay, and then minus t plus t squared. So this now is a perfect square trinomial. But we also have to subtract away 1/4, you know, to negate what happened here. So we're going to do that by subtracting it from this 1. 1 minus 1/4 is 3/4. And you can see that right here, what's in red, it adds up to be originally, you know, what we had originally, which is just a 1. Close this integral with a dt. All right, now we rewrite that as a perfect square, like a binomial squared, okay? Now we're going to have t, but minus what? Now it's a minus sign because the sign in the middle is a minus. You're going to take the coefficient in the middle and just divide it by 2. That's what you're going to add. So -1 divided by 2 is going to be t minus 1/2. And then that's going to square out. All right, so now to be able to really leverage the arctangent, you know, antiderivative identity, the denominator needs to be a sum of squares. So this is already adding, that's fine. Now let's rewrite this 3/4 as a square. And to do that, we just take the square root of the inside and then square it again. So now the question is, what is the square root of 3/4? Well, the square root of 3 you can't really change, so I'm going to write that down. But then the square root of 4 is just 2. Okay, so that's just the square root of 3/4, and we have the square. If you just go ahead and expand this out, you're going to get 3/4. Okay, now right here, let's go. You can go ahead and make a u substitution if you'd like, but it's not really necessary. Okay, it's just the shift to the right, and this right here is linear. So yeah. Now let's go ahead and take the antiderivative. Antiderivative this guy. Well, okay, let me remind you how this goes again. The integral, or sorry, the antiderivative of 1 over a squared plus x squared with respect to x is just 1 over a, and then arctangent of x over a. So let's go ahead and apply this here. And you can, by the way, you can get this through a trig substitution where you let x equal to a tangent theta. But that's pretty basic, so you should be able to work that yourselves. In fact, this is typically memorized in most calculus courses. 1 over a is just the reciprocal of a, okay? And our a value is this right here, root 3 over 2. So if we want to take its reciprocal, that's going to be 2 over root 3. Okay, next we have the arctangent. All right, in here we're going to have an x, and then we're going to, once again, divide by a, or multiply by the reciprocal of a. And, sorry, this isn't x. This is t minus 1/2. And then, okay, like I was saying, we divide by a, or multiply by the reciprocal of a, which is just 2 over root 3. Okay, so I'm going to keep this in parentheses because this is all inside of the inverse tangent. Now we plug in bounds from 0 to 1. Okay, and upon doing that, we get, what do we get? All right, let's plug in 1 first. 1 minus 1/2 is just 1/2. So it's just 1/2 of the inside of whatever's left. So 1/2 of 2 over root 3 is just 1 over root 3. So we're going to have, okay, this coefficient is going to go on the outside. We're going to have inverse tangent of 1 over root 3. Okay, and we'll work out the exact values later, but this is pretty simple. Plugging in 0, you're going to get, I think, the exact same thing. So subtract off, plugging in 0, you're going to just get negative 1/2. And since the arctangent is odd, the negative sign that's going to be here, we can move it to the outside. So let's put the negative there first. Now let's put arctangent. And then on the inside, well, we're just left with the 1/2 times 2 over root 3. And once again, the 2 on top and 2 on the bottom is going to cancel. We're going to be left with 1 over root 3. Okay, and that's it. That was very simple, but quite elegant. These are just both arctangent of 1 over root 3, so you're just doubling it. So it's just going to be 2 times one of these. The 2 we can just factor into this. So this is going to become a 4 over root 3. And then arctangent of 1 over root 3. This value right here, if you just take a look at the unit circle or something, it's going to just be pi over 6. So we're multiplying by pi over 6. Now, we can do some simplifying. This is 4 is 2 times 2. 6 is 2 times 3. One of these 2's cancels with one of these 2's. On the top, you're left with 2 pi. On the bottom, you're left with 3 times the square root of 3. And that is your answer for that sum.